Welcome back to Arcade. I am Super Tommy, and we're going to try something new today. We're going to go help out someone who has a problem. So I came across this in the Phaser discourse group, and it's this ultimate programmer has this problem. He's making a dungeon crawler. He wants his sword to rotate and face the mouse cursor, and using arcade physics to do that. Or he has a sword that uses arcade physics and wants to rotate. So the problem with arcade physics, some of you might know, is that the bounding box will not rotate with the sprite. And so he's got a picture here of the problem, and I actually had an idea, but I don't know if it's going to work. So my idea is actually similar to what I've done with missiles in the past. I can show you in the arcade blog. The workaround that I've done for homing missiles, which is a similar idea. You don't see this that well, but this missile is moving and rotating, but the bounding box doesn't change. What we can do is use a container and a circle collider, and that should give us a similar effect. And so we've done this here, but so his sword problem is not exactly like this. Given that the sword rotates from here and hits from here, where the missile rotates, doesn't really matter where, the tip, let's say, and then it hits at the tip as well. So this is sort of inverted. So what we're going to do is try to see if we can do this. I have not tested this. It's just an idea that I've gotten, which is to use a similar concept, container, circle body colliders, and then we can even put multiple circles along the blade and rotate those circles relative to the origin of the container. So I've got this project set up. You can see I've got this golden sword. It's rotating, and you see that the bounding box is not rotating with the sprite. So let's see if we can actually make this work. Now this actually may not work. I don't actually know. We're going to do this in real time. We'll see what comes of this. So this is just a setup code. So now let's just make our sword. We're going to call this sword container. So we're using TypeScript. If you're using modern JavaScript, everything should be the same. You just delete all the types. So we're import phaser. Let's make our class here. Export default class sword container extends phaser.scene. Okay. Oh no, not phaser.scene. Dot game objects dot container. Okay. Constructor. And what do we need? We need a scene. We need an X. We need an Y. I don't think we need to care about children in this case. So scene is going to be phaser.scene. X is a number. Y is a number. We're good there. Okay. So there's that. Okay, so we will want our sword, right? So we're going to call, let's say, display. I'm going to call this display. Phaser dot game objects dot image. Then see this dot display. Oops, not this. Display scene dot add dot image. So we call the sword. We'll just leave that as is. We could probably pass this in, but for now, we'll just leave it in there just to make sure this idea works at all. So this dot add, so we're going to add our sword display to our container. Now it's at 0, 0 on our container. Let's just make sure this works. Let's come out here, import sword container from sword container. So I've actually learned, let's just keep this. I've actually learned myself this week an interesting way of adding the container itself to the scene. So obviously, it's given the scene is passed here, we can do scene dot add dot existing this. So we'll see if we like this. I never actually tried doing it this way before, but basically we can do, so let's just, so this sword is going to be sword container type. So this dot sword gets a new sword container. We'll put it at 400, 300. Oh, we got to pass the scene. So this, and this should be added to the display list and draw. And there it is. Okay, so there's no physics box yet. I guess this is okay. There's no explicit adding to the scene since we do it in the constructor. There's some hidden information, but that's probably okay. We'll see. It's not bad. Okay, so now we can do this scene.physics.add this oh, sorry, dot add dot existing. So we should get a physics box. We do. Great. Okay, so what we want, so this would give our container a this dot body. So we're actually going to make, so in here, since it's multiple types, VS Code doesn't exactly know which type and doesn't give us as good code completion, but I like my code completion. So what we're going to do is add a little getter here. We're going to call this physics body so that we don't override the existing body property on the container. And what we're going to do is return this dot body as, so we know this is a dynamic body. So that's physics.arcade.body. So we know that. So this dot physics body dot set circle radius. So let's see. I'm actually going to make the sword stop spinning. Okay, no spinning. Stay in one place. Okay, set circle radius. We're going to guess 10. We just guess 10, no offset. What does that do? 10 is definitely too small, probably. 20. All right. Offset. So let's see. Let's get the, so display width. Well, I'll just say width. Width. This dot display dot width. Oops. Width. So that's the sword, and then height. This dot display dot height. So surely the offset, so this is x, so let's just go no x offset for now. Let's go up and down the y offset half height. Get it in a, oh no, wrong direction. Let's move up. So what is height? Height must be something huge. Let's try that. Fascinating. Let's try that. It's better. What is the height? Let's see. Let's go to our debugger here. Sword container. And let's see. Breakpoint. Run. Height is 140. Oh, it's a square. Yes. Continue. Let's continue. Go. Continue. Okay. So yes. So let's go. Const offset y. So we know we probably want half, right? I might just go crazy. So this is so half. And then since our radius is 20, let's see, minus half radius, offset y. Oh no, we still need to minus this. Let's think. well, okay, let's try just -10. Just offset the radius. And this -10. So that should be the center of the container. Oh no, wait, not diameter, radius. Math is fundamental. Okay, so that is the center of the sprite, and that is correct. And okay, let's put some more numbers here. Const radius is 20. So always want minus radius, and just to center it, so we have a reference point here, radius. So that's good. Doesn't matter what the height is, that's right. And now the width, so we want, what do we want? So if it's a sword, it's going to rotate from the handle, right? So back here, we know this is the center where the physics circle is. So that means this.display.x should be half over. Well, the handle's over there, so not exactly half over. About there. Maybe 3.35. Yeah, that's about the handle. And then, so let's see, what if we are rotating? What does this look like? Yep, that's better. So if our collision is there, what we're probably going to need to do, well, let's see. Let's see if this is going to do what I think, or we actually have to move it. So minus, so that's the offset. So 20 radius, offset y is, I don't know what we need to duplicate. I don't need another variable here, I don't think. Let's click that. Okay, so minus radius moves in the center, but way at the tip of the sword. Width, yes, very far. Half of the width. That's better. So now if we are rotating, what this do? I think this is going to be wrong. Yes, right. That will indeed be wrong. So of course in our missile, right, we had, let's stop rotating. In our missile example, we had the sword offset or the missile offset in a different way where the tip was the center, and then we left the circle collider in the center, so it just worked perfectly. So we're going to do a little bit different for this one. We just do some thinking. Is it possible? No, the collision is not going to move. That's how arcade physics works. So, okay, so we're going to decide we don't need this. So instead of adding a physics body to the container, let's try this. We're going to, let's call this physics object. It's mostly going to be invisible. We're using arc. I'm going to make a circle. I guess you could also make a square. Wouldn't really matter. We'll just use circle. And okay, scene.add.circle. No, yes, that's what I have to do. There's no physics circle. Let's just leave it at 0. We're going to make the radius the same. So radius. So we will need this, but on the circle. What else we got here? Fill color doesn't really matter because fill alpha is going to be 0. Okay, so this dot physics, not physics body, physics object. Okay, get that. Now, scene dot physics dot add dot existing this dot physics object. which means our physics body in this specific case is going to be the physics object body. So set circle, let's go with just the minus radius. Actually, I'm going to go with no offset. Well, what do we get? What do we get? Nothing. Because it's up there. I need to add this. No, scene dot. No. This dot add this dot physics object. Right. So we need to add it. So scene dot add adds it to the scene, of course. So we gotta. There we go. Add it to our container. Okay. Brilliant. So now we want. Let's see. It's going to rotate. It should just, yep, okay, great. That's what I'm expecting. Now we can move. Let's move this to width times half width. Okay, let's just actually see what the rotation looks like now. Okay, right. That's good. It's sort of what's what we want. So that's the body. So we can probably move this a little bit. Definitely not. It's not going to be at all width. That's probably pretty good for a sword. Okay, so we got that. So now the question is, we would need it to, of course, collide with other things. So let's do, let's make this dot add, this dot physics dot add dot, could do an image, but I don't have any images. So we're just going to make this dot add some other circle, not curve, circle. And let's see, we will do it so that 400 is the middle. What's 300 radius? Let's make it somewhat big. Fill color, white, 1. So circle, and then this dot physics dot add dot existing circle. You can actually, it says circle, but it'll have a rectangular bounding box. That's fine. Where is it? I don't want 300. 200. So if it rotates, will it collide? It may just not. But nonetheless, okay, this dot physics dot add dot collider. So we're going to collide this dot sword dot physics body. Can I do that? How about this? This may not be the best, but physics display. Oh, I can't spell. Physics display, and then return this dot physics object. Sword dot physics display, this dot sword, this dot sword. So it should, when I make this thing rotate, is that right? I'm not sure. Let's see if this actually does anything. Nope. Let's see. I think it just doesn't actually realize that it has moved. So let's actually just say, well, I think there is an update game. I don't want to do that. Let's just say, and then we're going to do this dot physics object dot update. I think statics. So it's not registering a collision. Okay, there probably is a workaround, but maybe we try this instead. So instead of adding this physics object to the container, so it makes me wonder if we need the container at all, but we'll just go with that. We are going to add the, so let's just stop it from rotating, it's actually distracting. Okay, stop rotating, great. Let's save this should be up there. Yes, so we're gonna offset this, just drop it down like this. So I'll try to make this easier for y'all to see. Let's drop it down here. So, okay, give it some spaces. So this is x, y, radius. So x, it's going to be x plus that, and then y plus 0. I think we just could omit the 0. Okay. And so when we rotate, so how about we do, let's add a rotate by, and then let's just say degrees, by default 1, and then we're going to do, so this dot angle plus degrees, right? So this is only going to rotate the sword, but not the circle physics object, game object we made. We need to rotate that as well. Let's just make sure this works. So this dot sword dot rotate by, we'll go set to, as expected. Now we want to rotate our physics object relative to the origin of the container. So const x, this dot x, const y, this dot y. Now, so let's see, we can do new phaser dot math dot vector 2 xy. Then I believe the vector has to pull. No, that's not what I need. I need to reverse that. I've done this. I don't remember anything. Let's see. So we want the inverse of this, right? What did I do here? Angle to vector. We have a vector, and we need to rotate the vector. Let's see. No, that should be right. Set to polar. If I give it the rotation, let's see. So this, that rotation, I don't think I need to care about radius. And then, so let's see, this is, no, this is that. Let's see, I think phaser has a built-in. Rotate relative to origin, or a origin. No, rotate relative to position, rotate around point. Yep, this may be phaser 2. This is indeed V2. Let's see. But I think phaser would also have this built-in rotate, just rotate around, actions rotate around X and Y. This is probably what I want. Let's see what's going on here. Rotate around distance. Phaser actions. What did I have going on? Rotate around distance. Phaser.io. Let's go to some docs. Let's see. I would, if I was this type of function, I would be in the math namespace somewhere. Math. It's probably not in the vector. Let's go to math. Math.angle. So that's angle between points, between y, counterclockwise, normalize, rotate to, shortest between, wrap degrees. I could do it manually, I just don't want to. Here there's another example. It doesn't seem clear that it's doing what I want. I only want actions. Geom align, rotate around point. Load. Yeah. Well, there's a line rotate around point. Is there a rotate around point just in general? What? Open spaces. It just searches everything. Rotate. This is not a good search. So I want rotate around point. I want point rotate around point. Line, triangle, line. So there is a phaser point, right? Maybe I need point. There's a point class. Seal, clone, copy, equals, floor, centroid, magnitude, interpolate, get magnetech, rectangle, invert. I can just do this. Rotate. Oh, there's nothing. Okay, there's no, but that's fine. I guess I can just, oh, nope. Let's just see, so that I can remember here, rotate around X, Y. Fair. Geom that triangle, let's start reading some source code. Source code phaser.geom. That line had it. So rotate around point. Rotate around XY. Oh, phaser has a rotate around XY. Rotate around XY. Yep, great. Rotate around XY. Is this not exposed somewhere? Guess not. Okay, that doesn't matter. But this is the basic algorithm we want, so let's just do it. All right, so that's origin, beautiful, which we don't need to do that. And now we want the position of, we're going to call this just px for the physics object, so this dot physics object dot x, that's py, this dot physics object dot y. Okay, the cosine is going to be math.cosine. The angle we're using is angle in radians. Yep, this dot rotation, and then sine, just math.sine, dot rotation. Rotate around x, okay. Tx, so we want, so origin is xy. The horizontal around the vertical, right. So we are going to do px minus x, const ty py minus y, and then our, let's not make this, we're going to actually update this. So px is going to be, so let's see what's going on here. We make, right. Right, because line has multiple x and y. Okay, so we don't care about that. So we're going to do times cosine minus times sine plus, nope, times sine plus x. And then ty times sine minus ty times cosine plus y. And then, well, I guess I could have just set it in there, up there, dot y, py. So that's rotate y. Okay, let's see if we did anything right. Okay, not rotating. Let's start some rotates. This could be wrong. That's not quite what. So let's, instead of rotating on update, let's rotate this dot sword dot rotate by. Just rotate by 10. Okay. Probably wrote this algorithm wrong, because that looks like the right rotate around point. Obviously, angle should be like 10 degrees, and then the rotation is going to be 10 degrees in radians over 400, 300. Physics bodies at 44, 300. Yep. X. Aha. Wait. I definitely wrote this wrong. Ta-da. Let's just continue. There we go. We don't need this breakpoint. Okay. Let's see. Let's get rid of this. I'll just rotate on the update. See what we got. So it's moving all the way back. Why is it doing that? So if I go update, rotate, drop this in here. I just stepped through it to 2 frames. It seems somehow my X is going all the way. It's not a precision problem, is it? That would be interesting. Tx, ty. Yep. Px, py. Wait, what? Okay. Let me set x, y. Okay. So that hasn't changed. That's correct. Rotate wherever it was. Yep, this seems right. It's px 43302. It still seems right. Let's just see. It's definitely moving into the center. 400, 300, did it move into the center? Did I actually do something else incorrect? Yep. So if y'all are interested in actually why this works, let me know in the comments. I can definitely do a more mathy explanation of the trigonometry. Well, this is still wrong. Because, yes, the trigonometry and math, how that works. So this is because my radians is crazy and we need to so if to offset it. So here's the deal. So the rotation is just math. So it's going from negative, let's move slower so I can actually see this happening. So since rotation is in radians, it's from negative, it's going way faster. Not doing what I think it's doing. Could be the diff. Do I actually need the diff? Okay. Start rotation. This that rotation. Well, we have to degrees. What we're going to do is this could be reversed. Minus, and we're going to go like that. But I don't think that's right. It is right, but it is in the reverse direction. So we're doing the difference in rotation, since this is called rotate by after all. Okay. Anyway, if y'all are interested in the actual mathematical explanations of why this is the case, I can definitely do that. I don't remember why all the math things work the way they do, but as needed, I do try to learn it when I have to. Okay, so now why are these colliders not colliding? Physics display. Now, of course, could be that I'm forcing the move, but that's okay. So what if I do dot overlap? Let's just see if we even get anything. Call back. I'm just gonna do that. Well, we're gonna, what does it matter? Overlap. That's all. Nope. So let's see. Let's see what we're actually doing wrong. Collider. So we're adding the sword physics display. Oh no, we're hitting ourselves. My God. Yeah, okay, let's go backwards. Bloop. So there's the hit. Bloop. So probably what you want, well, it depends how your game is going to be constructed. But if you were to, of course, it's also moving it. What you probably are going to do, if we use overlap instead, you're going to do something when that overlap happens. Let's say, oh yeah, this is Firefox, yes. So it's doing the overlap, you may want to like add some of your own physics or like give it an effect. So we're going to have, so this is the sword object, the first phaser.gameObjects.gameObject, and then the circle is the, I don't know, we'll call it circle for now. So that's what we're getting, although we know that anyway. So what we're going to do, the shadowing is probably going to be a problem. Okay. So we can say dot body, and then let's just say, let's see, where are we? We can get the directional vector, which is going to be sword object is going to be behind it. So circle object, it's a new phaser dot math dot vector2 circle object dot x. Oops, x. Let's drop this down here to see it better. Sword object dot x. Is there no x? Oh, it's a game object. Not necessarily with a transform, but we know it has a transform. So I actually think we can do phaser.components. GameObjects.components. Components.transform. That's going to complain. This will not be a problem if you're not using TypeScript, which is maybe why some of you don't want to use TypeScript due to these problems. So we're going to call this S. It's not, these are terrible. These are terrible variable names. We know it has a transform component. So I definitely don't suggest you actually use these variable names. That's a problem. Cannot do this. Unused, right? There's probably a better way to do this than this, but we're going to do this. All right. It's not recommended. I just want to see that this actually works. Okay, c.y, s.y. Here's my vector, directional vector. So we're going to go in whatever the vector direction is. So let's see, vec.normalize. So now we have a length 1 vector. So now we are going to, let's just like move this blue circle here, which we know is C dot body, oh no, circle object dot body dot C body. So we know this is a physics.rk.body. If you're not using TypeScript, you probably don't want to do this either. You can just do circle body.object, but I just want the IntelliSense set velocity, and we're going to give it Let's just say this may be too much. Maybe it may start flying. What does it do? Look at that. Maybe that's not enough. It should move faster than the rotation that I'm going. Bloop. And there it is. So of course, if you had a small enough thing, it wouldn't quite work. If the so like if you set it just big enough, it can just pass through right here. Theoretically, what you can do in that case is add another circle, just like we have here, and then rotate it, maybe in a smaller circle, and then rotate it around in the same way, and then you'll basically have a sword that you can rotate and hit things. So let me know in the comments if anything is unclear or you want to actually see the two circle colliders. And if you need help with moving the sword around to the mouse, I'm just rotating it just like this for a test. Let me know in the comments below, and be sure to subscribe to the Arcade channel for more great game making videos like this, if you thought it was great.